Hi, this is John Linneball of John Linneball Tutoring, and this is Solving Linear Equations. Solving equations is what I called when I was in 7th grade doing math backwards. And yes, for those of you who make a distinction between arithmetic and, in quotes, real math, it's doing arithmetic backwards. And one thing that we run into in algebra is a lot of times we have to find x. So you can't just circle it and say, here it is. And as humorous as this is, dear algebra, please stop asking us to find your x. She's never coming back, and don't ask why. That's not what they mean. So the idea is instead of something like 4 times 5 equals 20, it's 4x equals 20. So they put a variable where 5 should go, and then they want you to find out, well, what is x? So solve for x or find x. Or isolate the variable. Or as the classic rock group Heart would, get you alone. Okay, anyway. The steps for solving linear equations. The easiest equation to solve is a linear equation where the highest power of the one variable, usually x, is 1. So it's just x, it's not x squared, it's not x cubed, it's not the square root of x. It's just called a first degree equation. So the reason it's called linear is because if you graph out an equation like that, you get a line like this or a line like this one. And if you have two linear equations that aren't parallel lines, then they'll meet at one point. So you can solve it graphically, you can solve it algebraically, etc. All right. So the first step is to eliminate the fractions and the decimals. I am here to terminate the fractions and the decimals. Okay, thanks, Arnold. Anyway. We're going to eliminate all fractions and decimals by multiplying both sides by the lowest common denominator. So first, let's make up an example. I literally just made this up. 1/4 x plus 1/4 x plus 4 times x minus 1 equals 2 times x plus 2 in parentheses plus 2. So the first thing we're going to do is multiply by 4. So this 1/4 goes away. So that gives us x, because 4 times 1/4 is 1, then 4 times 4 is 16, so it's going to be 16 times x minus 1 equals 8 times x plus 2 in parentheses, and then 2 times 4 is 8. So we have x plus 16 times x minus 1 equals 8 times x plus 2 in parentheses plus 8. So the next thing we do is distribute. So we do the a times b plus c is equal to ab plus ac. So our previous example becomes x and then times 16 plus 1 equals 8 times x plus 2 plus 8, so we distribute. So this 16 times x, that's 16x, 16 times minus 1 becomes minus 16, 8 times x becomes 8x, 8 times 2 becomes 16, and of course the 8 still stays the same. So the next thing we're going to do here is combine like terms. So now that the parentheses and fractions / decimals are gone, it's very easy to combine like terms. So you might be asking, hey John, what the heck is a like term? Like terms are if you have just plain numbers like a negative 16 and an 8, those you can add together. 16x and 8x, since there's the same power of x, the same degree, you can add that together. And 16x plus x, you can add that together. So first we're going to add, so first we have 16x and x, make that 17x. And then we're going to have 8x, we're just going to do that. So we have 16 plus 8 is 24. So we're just adding the like terms on each side, so I might have confused you a little bit before. So x plus 16x, 17x. Negative 16, negative 16. 16 plus 8 is 24. 8x is just 8x. And now what we're going to do is we're going to get all the variables on one side and all the plain numbers on the other side. So this is step 4. We're going to add and subtract the variable on one side and all the normal numbers to get that on the other. So we now have 17x minus 16 equals 8x plus 24. So what I would do is add 16 to this side to get rid of this negative 16. So we have 24 plus 16 is equal to 40. Let's subtract 8x to get rid of the 8x on the same side. So that's going to be 8x minus 8x, gone. 17x minus 8x, 9x. So now 9x is equal to 40. So We're getting closer to what Hart wants, which is to get you alone. Okay, and let's give a little pep talk. Your life will get better when you realize it's better to be alone than chase people or variables or numbers that don't really care about you. And come on, X, it's better to be alone than to be with someone who makes you feel alone. And get comfortable with being alone. It will empower you, X. So, all right, so let's move on. Step 5, divide both sides by the variable's coefficient. So the variable has a coefficient, that's the number that the variable is being multiplied by, which is 9x. 9x equals 40, so we just divide by 9. 9x over 9 is, of course, x. And since we have to do the same thing to the other side, we end up with 40 divided by 9. X equals 40 divided by 9. Hey, there's an answer. We have a variable on one side, a number on the other. You've solved the problem. So we're done. Awesome. Occasionally for second degree equations, that's where x or whatever variable you're using has the highest power of 2. So, the highest power of the variable is the variable squared. You have to use factoring, completing the square, or the quadratic formula most of the time to solve those problems. But for some problems, you can just isolate the squared variable. That is, get x squared, or whatever, squared alone, and then just take the square root of both sides. Works really well if x is positive. So you have an example here. Solve for x in terms of y if x is positive and y equals 3x squared minus 13. Y if x is positive? Well, otherwise x could be negative, since x squared is going to be the same as negative x squared. If you take negative x and square it, it's the same as if you squared positive x. So if x is negative, we don't really know whether to add or subtract. Makes the problem a lot harder, if not impossible. So that's why most of the time on the SAT, if they give you a problem like this, they'll just tell you x is positive. So it's really easy to solve this equation using the 6-step method, or as I've written it, the 5-step method. It's the 6-step method in the Barron's SAT book, Premium Study Guide, 38th edition. So anyway, whether you call it the 5-step method or 6-step method, doesn't really make much of a difference. Well, I guess here actually it is a 6-step method because we're going to take the square root. So anyway, however you look at it, we go, there are no fractions and no parentheses and no like terms to combine, so we just add 13 to each side to get y plus 13 equals 3x squared. So now we're going to divide by 3, which is our step 5, to get y plus 13 over 3 equals x squared. So now our special step 6, or which is step 7 in the Barron's book, but doesn't really matter. Anyway, we're going to take the square of both sides to get x. So we get x equals the square root of this thing here. So it's going to be the square root of y plus 13 over 3. So we take the square root of that whole thing, and that's it, because we can't solve it any further because you have 2 variables. So we're done. The other methods for solving quadratic equations, that is factoring, completing the square, or using the quadratic formula, will be covered in another video, I promise. You can use this method to solve in terms of other variables in other kinds of problems where, again, you just treat the variable for which you are solving as, in quotes, the variable in an equation with only one variable, and treat the other variables as plain numbers, that is, constant. D equals RT. We all know that formula, distance equals rate times time. You want to figure out how far you're going to get driving at exactly 60 miles per hour for 2 hours. Well, okay, 60 times 2. Oh, okay, so we're going to drive exactly 120 miles. If we want to solve for the rate R, we just divide both sides by t to get R equals d over t. So the rate is just the distance over the time. I'd like more practice, please. There's linear equation solving help available. There's a YouTube video right here. I also will have that in the description beneath this video. West Texas A&M. It's a college that has posted many helpful math pages. I've used lots of them in my tutoring. And this particular one, to which I will have a link in the low bar, or you can just look at this video, pause it, and copy it, gives you, again, pretty much the same 6-7-step method for solving any linear equation, and it gives you a lot of additional explanations. The College Board, of course, has practice SATs available, so you can use that. They're full-length tests. You can use that for math and English and whatever practice you want. And it also, of course, will give you a good idea of what you should expect to have on the SAT, since these are practice tests made by the actual SAT people. Did you find this video useful? I hope you did. Please like it and subscribe to this channel. Neither action costs you anything. You'll be alerted about my new videos. Why do I care? It's simple. YouTube does not share any ad revenue with me unless I have 1,000 subscribers and 4,000 hours of view time in a year. While many people are watching these, I don't have 4,000 hours of watch time. Still don't have anywhere near 1,000 subscribers. Last I checked, I had 650 or 649, something like that. Anyway, for the same reasons, you are not only welcome, but encouraged to share links to this video, put it in playlists, etc. Just please credit me with it, okay? I mean, I put work into it. I'd like you to at least acknowledge who did it. Anyway, I'm always happy to read and respond to constructive criticism or suggestions for new videos. I do reserve the right to delete comments from and block those who specialize in destructive criticism, trollers basically, or things that are off topic. That is, people who want to spam whatever product they're trying to sell, or just disturb people who decided that it's easier to spam YouTube comments than get counseling. Anyway, contact me if you like. My cell phone number is 415-623-4251. Again, it's 415-623-4251. You can text me on that number if you like. My email is john@johnmenabal.com. If you want to send me actual postal mail, you can do that at 1859 Powell Street, number 109, San Francisco, California, 94133. Thank you so much for watching. Hope you're having a great day.